Everybody who's joined us today, and thanks for coming along. I'm very pleased today to bring to you Mr. Paul Bibby, Managing Director of Akora Resources, who'll be presenting a briefing here on Bekisopa and the Magnetite material that this project holds. I'll transfer across to Paul right now. At the end of the presentation, we'll have the opportunity to discuss via a Q&A session. So thanks for attending, and over to you, Paul.
Thank you very much, Peter. Thank you all for joining the Akora Resources webinar today. I'm going to talk to you about the Bekisopa project, and in particular, the magnetite outcropping and the magnetite that we are seeing beneath surface and along strike at our main project, Bekisopa. This cover slide you've seen before, and it shows these massive boulders of magnetite on the surface. We did 118 rock chip samples of this outcrop material, and the average grades were 66.7% iron, 1.5% silica, 1% alumina, 0.07 phos, and 0.06 sulfur. So in spec material for feed to the blast furnace. It is lump ore. It is solid rocks of magnetite. The maximum grade that we saw was 69.8% iron, and 21 of those 118 rocks were over 69% iron. In the bottom left-hand corner there of the slide, I've put what is the theoretical maximum content for magnetite, which is 72.4% iron. So pure magnetite without any impurities, the iron content is 72.4. So having rocks at surface grading 69.8 and 66.7 on average is pretty close to being pure with very little silica and alumina type impurities. Pure magnetite, which is what we see in the Pilbara, has a maximum iron content of 69.9%. And we do have some hematite at Bekisopa, but from what we're seeing so far, it's predominantly magnetite. The outcrop is massive lumps. And as you can see there from those two images, from the pen on that one and the geologist hammer on the other, these are massive lumps of rock. Lumps like this one, which I have in my hand here, which is basically solid magnetite grading 66.7% iron. And all we need to do for this rock here is to crush that to 25, 30 millimeters in size and feed it to the blast furnace. That's about as complicated or as straightforward as the processing needs to be. The outcrop, which is magnetite, and through the drilling program, we're going to understand better the extent of this outcrop below surface, whether it's large bands of this massive high-grade magnetite or combinations of the magnetite with the country rock. Some of these rocks are almost metallic, like this rock here, and the two images that I'm showing you. Very high-grade material. The processing for this to make a saleable high-grade lump and fines iron product is conventional mining, crushing, screening, and some magnetic separation. Very straightforward, conventional processing, low capital cost, low operating cost ongoing, and high margin premium lump product and fines product to be produced. At Bekisopa, we're also seeing that from the drilling, there's a couple of layers of material, and there's possibly a third resource component that we're looking at. And this is the disseminated magnetite in the country rock, where we're seeing 2 millimeter or 3 millimeter particles and 1 millimeter particles of magnetite grading 65, 67% iron in the country rock. Our expectation is that this will be a high-grade coarse magnetite aggregate that should separate out fairly readily with crushing and magnetic separation to produce a fines iron ore product. If you look at the drill core that we produced in 2020 from our drilling campaign, I've got 3 or 4 images here, which shows you what we're seeing at depth below the outcropping material at Bekisopa. The image here at the top of the slide is massive magnetite. If you look at that image, the dark grey to black material is magnetite, and the grey areas are a calcite material, calcium, silica, alumina type rock. So this drill core is about 60 millimeters wide and these intersections of the dark grey material of magnetite is around about 90%, I would say, of the drill core in this area. And this magnetite will have a product grade of around 66%, just like this material here that we're seeing on surface. So high recovery from that massive magnetite and very high grade. A secondary resource, which is this coarse disseminated magnetite in calcite and amphibole, is shown on the bottom slide here. And what you see again is the dark grey material, which is the magnetite, grading 60–65% iron. We'll know better when we get the analytical results in the coming days, with the country rock material. In this image here, the estimation is there's 45 to 55, maybe 60% magnetite in this drill core, and the rest being country rock, readily separated through conventional crushing, screening, and magnetic separation. The next two images of the drill core, again, is the coarse disseminated magnetite. And in the top image, you can see spheres of the dark grey magnetite. Remember, the drill core is about 60 millimeters wide. So these spheres are 15, 20 millimeters in diameter, 30 or 40 millimeters in diameter, the size of a golf ball. And again, there's around probably 40 to 50% magnetite in this section with the country rock. When that is crushed, you can expect that the magnetite will fracture around the grain boundaries of those magnetite spheres and produce a high-grade lump and fines product. A tertiary resource, this is something that was unexpected until we did the geological work late in 2019, is that there's this finer magnetite, the black and the greys in this rock. It's probably only 15 to 20% magnetite, but again, when it's upgraded, it could be able to produce a 60–62+% iron product. For us, this is a tertiary resource. It's not what we're focusing on, but it's there, and down the track, it could be an added product, added income stream to the Bekisopa project. So hopefully that explains what Bekisopa is like. And the top image here of the drill core is our target. This is what we see as our focus resource, the primary resource for Bekisopa: large, massive, magnetite, high-grade material to produce lump and fines product. In comparison, there is the banded iron formations, the classic West Australian banded iron formations, but found elsewhere around the world. And this is a beautiful photograph from the Karijini National Park in Western Australia. And what it shows is the red lines there are the iron mineralization, the white is the silica. And if you look at that and cast your eye over it, you'd probably say that the white is the majority if you did a vertical line from top to bottom. And as a result, the typical composition of this is around 30% iron, 45% silica, and 5% alumina. In the next few slides, the numbers I'm going to talk about are just for demonstration. They're not from any actual project or anything, but just to demonstrate the difference between banded iron formations and the magnetite we're seeing at Bekisopa. So a banded iron formation is layer after layer, like a lasagna, iron, silica, iron, silica. It's rare to have the bands as wide as they are in this image. This photograph is what's typically encountered in mining situations. It's one of my photographs from my set of samples collected over the years. And what it shows is magnetite bands, the black lines, the black bands here, less than a millimeter or so in size. And if you look closely at some of these black bands, they've actually got striations in them of white, which is the silica. So as a result, the indicative analysis of this material would be 30% iron, 40% silica, 5% alumina. So it needs to be upgraded to produce a saleable product ready for the blast furnace and steel making. So it needs to be ground to 50 to 75 microns to produce a concentrate that will grade around 65 or 67% iron. So a lot of grinding to do that, a lot of power required to do that. One of the numbers you'll often see is DTR, Davis tube recoveries, and we'll be doing that for Bekisopa, which is just part of putting the resource, the JORC compliant resource together. You'll see a number for this type of material being 20% Davis tube recovery. What that really implies is that you need to mine 5 tons of ore to produce a ton of product. So for these banded iron formations, the mining cost straight away is 2 to 3 times higher than what it should be for a typical high-grade iron ore project. The process to produce a saleable concentrate from this type of material is conventional mining, crushing, screening, and magnetic separation, like what will happen at Bekisopa. But then to recover the iron from these narrow bands, you need SAG mills, ball mills, high-pressure grinding rolls, low-intensity magnetic separation and the like, dewatering of the fine product, and you'll also need space for tailings dams for all of this waste material that isn't going into the product. The fine concentrate is then sintered into pellets to feed into the blast furnace. This is another example of banded iron that's often encountered in mining situations. The magnetite band is less than 1 millimeter, the white silica, but they're not necessarily discrete bands, but it's certainly layered, as you can see. The indicative analysis of this material will be around 15% iron, 50% silica, 8% alumina. So very high in silica and alumina, which needs to be removed before that can be fed as a suitable product to the blast furnace. It needs to be ground to 25 to 50 microns, very fine. 25 microns is the size of talcum powder, Johnson's baby powder type material. And that's what this material has to be ground down to produce a concentrate to grade 67%. Material like this would have a 15% Davis tube recovery, which means you've got to mine 7 tons to produce a ton of product. So in this case, the mining cost alone before you get into processing is at least 3, maybe more times greater than it is for conventional mining of high-grade iron ore material. So as a result, grinding of these banded iron formations to separate the bands of magnetite away from the silica requires high capital costs, grinding, dewatering, and tailings, and high operational costs. And if you remember back to what happened 2 or 3 years ago at Vale, their tailings dams, a couple of those collapsed, which was very, very unfortunate and concerning. But that's the sort of space you need and the processing you need to recover the iron from these banded iron formations. So quite a different product, very different in terms of being 25 to 50 microns and a lot more processing. This is one of the images from my collection, and what it shows is drill core for a banded iron formation that is around, I think, 35 to 40% iron, 40% silica. And what you can see right across these images are just black and white striations. The black being the magnetite, the white being the silica and alumina. You need to separate that magnetite out. These bands here are less than 1 millimeter in size, so a lot of fine grinding is required, a lot of power to produce a concentrate from this material. So in summation, what I'd like to say is that not all magnetite iron ores are the same. Typical banded iron formation magnetites require significant processing, including fine grinding and separation to upgrade the iron from, say, 20 or 30% to a saleable 65% iron concentrate product. This concentrate is typically around 25, 75 microns. This is what you'd have to grind to in Australia. It's what they're grinding to in the Labrador Basin in Canada and elsewhere across the Northern Hemisphere. And as I said, 25, 50 microns is the finest of talcum powder. So quite a lot of grinding, a lot of power is required to produce that concentrate, which then needs to be sintered, increased in temperature to make pellets to be fed to the blast furnace. So a good source of iron ore, no doubt, because it's high-grade material, but a lot of processing and capital costs required to produce it. And as I say there, high capital costs and ongoing higher mining and processing costs. And you also need land and management for tailings. At Akora, the Bekisopa outcrop material is high-grade iron ore lump. But rocks like this one here, which is basically almost pure magnetite. It is destined to be a lump product. Its size will be between 6 and 32 millimeters. So all it needs to be done is to crush, screen, and load that onto a ship and into a blast furnace. The 2020 drilling program that we did on listing last year indicates at least 2 layers of iron mineralization and possibly 3. at depth and along the 7-kilometre strike at Bekisopa. The secondary one is the coarse magnetite sections, which we believe should be able to be crushed and magnetically separated into fines, which is a less than 6mm size product. So relatively simple, conventional processing, straightforward mining, low capital costs, low operating costs to produce a premium iron ore product for steel making. So hopefully that's given you a bit of background as to the differences between the more typical banded iron formations and the magnetite that we're seeing at Bekisopa. I'd now like just to update you on the timing for the analytical results. The prepared samples were delayed leaving Madagascar, firstly because the Christmas break was extended because of COVID there, and then there were short shifts at the laboratory, again limiting people contact because of COVID. And the cargo options were only 2 or 3 flights out of Madagascar a week, and every second one seemed to be cancelled, so that caused us issues. All of the samples are now out of Madagascar. We're using the ALS laboratories in Ireland for the XRF analysis and Perth for the LIMS testing. We were originally going to go to Johannesburg, which is a terrific laboratory. It's a 2-hour flight, so you can transfer the product from Madagascar to Johannesburg in a day and be in the laboratory. Unfortunately, with COVID and the logistics, it's taking us between 10 and 17 days to get material from Madagascar to Ireland and Perth through customs and the like. So that's been very disappointed. The initial results are due in the coming days. So we'll start to get the results at the end of March. It's taken a lot of work. There's 765 pulps for XRF analysis. So from those 12 holes, we're taking samples at every metre where there's mineralisation to have them analysed for iron, silica, alumina, etc. We've also got 709 samples at 2mm fractions and 360 at 10mm fractions that have been coarse crushed from the drill core, and we're going to do some LIMS testing. LIMS is low intensity magnetic separation. That rig there on the right hand side shows you what that is. That's being done in Perth, and that's to look at the recovery and grade and separation at those sizes from the drill core. The 10mm is indicative of a lump grade product, the 2mm of a fines grain product, and give us some indication of how those recoveries and grades are looking from the drill core. As we get the results, they will be released, and we're expecting the first results to be published after the Easter break. So thank you very much for your time, and love to take some of your questions.
Thanks, Paul. And you've probably answered some of the questions that had come through. The one concerning the delay on samples returning, so you've covered that quite well. I think we'll understand that.
Yeah, I hope so. I guess the two things that really caught us out were the reduction in manning in the laboratory, which meant things took longer than they should have taken, and then not being able to fly to Johannesburg because of that South African COVID strain. And all of the cargo flights from Madagascar were directed to Germany, then from Germany elsewhere. So it's taken a lot longer than we planned for originally.
And something here in Australia, we're sort of forgetting that Europe's still suffering pretty severely from very high rates of infections, whereas we're living a pretty free lifestyle.
Yes.
One question here, and you probably answered some of this, given the outcropping material that you're seeing at Bekisopa, what are your expectations for the underground rocks?
It's hard to know, but the drill core, I showed you a couple of photographs of the drill core. Let's see if I can go back to that. There we go. So there's some photographs of the drill core. The one there at the top with the large grey mass on the drill core, that's 90% magnetite in that section of the drill core. So it'll be interesting to see what that grades. My expectation is that those massive lumps of magnetite are going to grade 65+%, certainly better than 62, you would think. And we're looking forward to getting the results of that. On mining, you have to imagine that if that's a 10-metre wide band, that's going to be massive big rocks of magnetite, which will need to be crushed and screened to a lump product. And then there's this coarse disseminated magnetite, which is the image there at the bottom. but also the second image where you've got these blobs, which are spheres of magnetite, 10, 20, 30 millimeters in size in that piece of drill core. They will fracture out in crushing to produce a lump product. So that's what we're seeing in the drill core. You'll never know until you get an excavator in there, but it's encouraging signs from those couple of pieces of drill core which I've shown.
Paul, the questions come through is a good one. What's the COVID situation in Madagascar, and is there any expectation the exploration program may be affected by that?
A great question. I was talking with my contacts last Thursday, Friday. The COVID situation has jumped up, unfortunately, in the past month in Madagascar. They're having a couple of hundred cases, 150, 200 cases a day, and I think 4 or 5 deaths from memory a day, which is very concerning. They were letting people into the northern part of Madagascar where the tourist locations are at Nosy Be and the like. They've been stopped in the past week. They were reporting the COVID only on a weekly basis. So people had sort of stopped the focus and the attention on social distancing and the like. And as a result, the cases have increased. There's no sign of a lockdown. The government's gone back to emphasizing that COVID is still there. They're reporting daily and putting in place all of the measures that we're doing here routinely. And at this stage, there's no signs of a lockdown. I'm concerned that there might be if they don't get this past couple of weeks number of cases down to an acceptable level. If there was a lockdown, you would expect it to be a typical sort of 4-week lockdown, which would mean that we couldn't get into drilling until May. We'd lose a month or so. In the scheme of things, I'm not so worried because we're looking to have 2 drill rigs on site to do our drilling program and have the drilling finished by August or September. We'll progressively prepare the samples and get them out in smaller batches earlier rather than wait till the end like we did last time, and have that resource reported by November, December. So I am concerned about COVID at Madagascar. It has jumped up, but we're monitoring it and we're looking to ways to manage it to get back drilling as soon as we can, ideally by the end of April. The wet season hasn't finished in the south, so it's a bit of an unusual one. We would have expected it to be less rain by now. So we're probably not likely to get into drill until the middle or end of April. And if there's COVID, it might push us out a few more weeks past that, which will be a concern. But in terms of what we've learnt from last year's program, we're still pushing to have a resource reported November, December of this year. Thanks, Pete.
Okay, and a good question here. Recently, some shares came out of escrow. Can you tell us where the shares have gone and perhaps comment on the makeup of the current register?
Yeah. Okay. When shares come out of escrow, as you know, we've got to do it's standard compulsory reporting. That was flagged last Monday. There's an announcement going out today saying that those shares are now issued. You've got to give them a week's notice. Those shares have gone to a shareholder that is a holder. They are not looking to sell. They've actually been in the market buying since we've listed. They purchased a parcel of shares that were from an existing shareholder that was happy to realise the sale of those before IPO. It's of no concern. Investors shouldn't be worried that there's going to be, I think it's 270,000 from memory type shares, that those shares are going to be put up for sale. The person that holds them isn't looking to sell. So it's just a formality, unfortunately, that we have to do to inform the market. I can't hear
mute button. Yeah, that's right. Mute button. Well, thanks, Paul. We've had a pretty good session here today. It's a good number of people participating. This webinar will be available on the website, and for people can to view at their leisure again if they would like. Anything else you'd like to comment on while we're here?
I guess the 2 things, just to reinforce that not all magnetites are the same. Our magnetite is high-grade lump product is what we're focusing on at Bekisopa. Conventional mining, crushing and screening to produce a saleable product for the blast furnace. And as the test results for the analysis of the 2020 drill program and the low intensity magnetic separation results become available, we'll be reporting them straight away, which will be, I think, straight after Easter. So looking forward to those results. So thank you everybody for your time, and thank you very much for your support of the Akora Resources projects.
Thank you, Paul, and thanks for all those attending today.